Good morning, sir.
Right. I'm not going to discuss all the questions of this paper. This is paper number 2. This normally this is given. These are given in my theory classes. But today I decided to give this to you also. Normally this is given for theory class. You see this, right? And these are practicing papers. It means basic theory fundamentals can be practiced by using these papers. Right? It's very good for you to learn theories. That's why I gave this paper. I'm not going to discuss all the questions. I just want to discuss up to question number 4. I just want to discuss up to question number 4, right? After that, I'll give. I'm going to discuss separate paper, separate questions. Right. Okay, give a try. Within 2 minutes, 2-3 minutes, I'll start question number 1. I'll discuss up to 4. After that, let's start another paper, another questions. The rest you can try at home.
Recording in progress.
Okay, let's start the discussion. Right. I'm not going to discuss all the questions. Find the units and dimensions of linear momentum. Write down the law of conservation of linear momentum. Right. Can you see the board here? Right. First, they ask us to find the units and dimensions of linear momentum. Are you all able to hear me? Hello?
Yes, sir.
Yes,
Yeah.
sir.
Yes, sir.
Quick theory paper 2, question number 1. Under that, you may have written the answers. Sometimes you may have written the answers. Sometimes you may have not written the answers. Whatever it is, please write in. Please write my answer separately. Please write my answer separately. The linear momentum of a moving object. The linear momentum of a moving object is defined as the product. The linear momentum of a moving object is defined as the product of its mass into velocity the linear momentum of a moving object is defined as the product of its mass into velocity. The linear momentum of a moving object is defined as the product of its mass into velocity. Look at board. Let's say there is an object. There is an object of mass simple m kilogram. This object is moving. These questions are essential to understand the theory, right? With a velocity of v meter per second. Then it is defined linear momentum. Linear momentum of this moving object is defined as the product mass into velocity. So mass is measured by the unit kilogram. Velocity is measured by the unit ms minus 1. So therefore, the SI unit, therefore the SI unit of linear momentum, SI unit of linear momentum is kg ms minus 1. Write it here. Draw the figure and write down the equation. Right? How do you find dimensions then? How do you find dimensions? Dimensions of linear momentum. Dimensions of linear momentum equal dimensions of mass into dimensions of velocity. Dimension of mass is capital M, dimension of velocity LT minus 1. Therefore, dimensions of linear momentum is MLT minus 1. Write them. Write it also. Okay, after that they have asked us to find write down the law of conservation of linear momentum. So please write. Whether you have written the answers or not, please write, because these things are something like some kind of revisions here, right? So write something like writing a short note. So if you write these things, it will be a big help for you to remember. Got it, dear? So therefore, sometimes you may have written them earlier also, but right. Okay, please write. It's better if you write it like a subheading. The law of conservation of linear momentum. The law of conservation of linear momentum. The law of conservation of linear momentum. Underline. The law of conservation of linear momentum. Underline it. And then please write the total linear momentum of an object or a system of objects the total linear momentum of an object or a system of objects. The total linear momentum of an object or a system of objects, comma, is conserved. The total linear momentum of an object or a system of objects, comma, is conserved along a direction, where there are no external unbalanced forces. The total linear momentum of an object or a system of objects, comma, is conserved along a direction where there are no external unbalanced forces. Right, would like if I repeat it? Anybody in the class? Okay, I'll repeat. Some of the students were not able to write it, so let me repeat. Please write the total linear momentum. The total linear momentum of an object. The total linear momentum of an object or a system of objects. It means there may be more than one object. The total linear momentum of an object or a system of objects, comma, is conserved along a direction where there are no external unbalanced forces. Along a direction where there are no external unbalanced forces. Okay, dear? Right. Star point and write. Star point and write. Star point and write. The law of conservation of linear momentum. The law of conservation of linear momentum can be represented by the law of conservation of linear momentum can be represented by the following equation. The law of conservation of linear momentum can be represented by the following equation. Look at board. Look at board. The total initial linear momentum. What is the meaning of the word conserved? Total linear momentum is conserved along a direction where there are no external forces. It means if there is a certain direction, if we have not applied any external forces, any external unbalanced forces along that direction, the linear momentum along that direction is not changed. Starting total linear momentum will be equal to the final total linear momentum. So total linear momentum is not changed. Not changed is said to be conserved. That's the meaning. So the initial total linear momentum equals to the final total linear momentum. To the final total linear momentum. Please write. This is the equation that we use to solve problems. Therefore, please write this equation and draw a box around it. Write this equation and draw a box around it. Start there. Okay, now let's go to question number 2. Let's go to question number 2. Sorry, question number 2 asks, find the units and dimensions of kinetic energy. Write down the law of conservation of kinetic energy. So what is question number 2, dear? Find the units and dimensions of kinetic energy. Write down the law of conservation of energy. Right. Kinetic energy. No need to draw separate figure. We have this one. For the second question, kinetic energy is defined by the equation half mv square. Half mv square. Mass is measured by kilogram. Velocity is measured by ms minus 1. But velocity square is there. V square. Therefore, we should get the square of the velocity. Write it. Please write it with me. So therefore, the SI unit of kinetic energy is kg. Mass is kilogram. Velocity is ms minus 1. Ms minus 1, but we have to get the square. Can you simplify and check the final answer? What will you obtain as the final? So this is kg. If you get the square of m square s minus 2. Kg m square s minus 2. But what's the unit that you have heard for all the forms of energy? Not only for kinetic energy, for all the other forms of energy. For all the forms of energy, we have a unit called joule. How do we get joule here? It is done like this. Look at board here. I can write kg. M square can be written as m into m. M square can be written as m into m. Let me take one of the m term to this side. Then I'll get kg ms minus 2 into m. No difference. M into m, m square. No difference. But what is kg ms minus 2, dear? What is kg ms minus 2? Do you remember Newton's second law of motion? F equals ma. Do you remember this? F equals ma. So force is measured by Newton, mass kilogram, acceleration ms minus 2. So kg ms minus 2 means Newton. Kg ms minus 2 means Newton. So Newton meter. Kg ms minus 2. Newton meter will be that. Newton meter is the SI unit of kinetic energy. But as a honor to the scientist Joule, all the forms of energy is named as Joule. So finally, we can write Joule. So please remember that to represent kinetic energy as the unit of kinetic energy, we are able to write use 3 units. First one, kg ms minus 2, Newton meter, or Joule. All the 3 are acceptable. Please complete this and write the note also. Start there. Right, now we want to find the dimensions. We want to find the dimensions of kinetic energy. Let's do it also. These for the first 4 questions, something like a revision for you. Something like writing a short note for you. Right? So you try the other questions at home. Right. Dimensions of kinetic energy. Dimensions of kinetic energy equals dimension of mass, dimension of half actually, dimension of mass, dimension of velocity, and square of that. So half is the number, so I put number 1 for there to indicate that no dimensions. Numbers do not have dimensions, please remember. Half is the number, numbers do not have dimensions. Then mass, dimension of mass, capital M, dimension of velocity, LT minus 1, but square is there, you see. So finally we get M L square T minus 2. What's the dimension of kinetic energy here? ML square T minus 2. Complete it there. After that, they have asked us to write down the law of conservation of energy. So please write the law of conservation of energy. Law of conservation of energy and underline it. Below it, please write. Below it, please write the total energy of an object. The total energy of an object or a system of objects. Law of conservation of energy, underline it and write the total energy of an object or a system of objects. The total energy of an object or a system of objects is conserved. Is conserved. The total energy of an object or a system of objects, comma, is conserved. Is conserved. Got it? Who would like if I repeat it? Anybody in the class? Right. Star point and write. If you won't repeat, please tell me. Right. Star point and write. Star points and write. The law of conservation of energy. The law of conservation of energy can be represented by the following equation. The law of conservation of energy can be represented by the following equation. The law of conservation of energy can be represented by the following equation. Can somebody guess the equation? What may be the equation?
The total initial
Yes, try.
energy equals to the total final energy.
Very good. What is it?
The total initial energy.
Very good. Initial total initial energy of a system or a system of objects equals to the total final energy. So energy is not changed means initial total energy of an object or a system of objects should be equal to the total final energy. Complete it here. Write it. Okay, now let's go to question number 3. Question number 3 tells us a metal ball is dropped from a height of 100 meter. What is the velocity of the ball when it hits the ground? A metal ball is dropped from a height of 100 meter. What is the velocity of the ball when it hits the ground? When it hits the ground. So that is question number 3. There are 2 methods to answer this question. So I'm going to explain you both methods. To obtain the answer for question number 3, there are 2 methods. Let me erase this side. Look at board. The first method is for the question number 3. Let me draw the figure first of all. A ball is dropped mean initial velocity is 0. It falls freely under the gravity and it hits the ground with a certain velocity. Let me mark this velocity as v meter per second. Something is dropped mean initial velocity 0. You take it and dropped. Dropped mean initial velocity 0. So it hits the ground with the velocity of v. We know that when an object falls freely under the gravity, its acceleration is simple g meter per square seconds. Let me mark the starting point of the motion as capital A, ending point as the capital B. So the first method is A to B vertically downward. I can apply the equation v square equals u square plus 2a s, because it is given in the question that this distance is 100 meter. Draw the figure, use the first method and try to find the velocity v. Give a try here. Give a try. After that, I'll teach you the second method. Final velocity is the thing that we want to find. Initial velocity 0 plus 2 acceleration simple g s. The displacement of the object from A to B 100 meter. 100 meters. So 0 square is 0. 2g is 10. This is 100. So v square equals 2000. Therefore, v equals square root of 2000. But this can be further simplified. Square root of 2000 can be further simplified. Somebody please give me a method.
400 into 5.
Very good. 2000 can be written as 400 times 5. You see, 5 times so 22,000. Therefore, v equals square root of 400 is 20 root 5. 20 root 5 meter per second. So this is the first method. So what may be the second method here? Second method is we
Law
apply,
of conservation of energy.
Yeah, we apply.
Law of conservation
Very good.
of energy, sir.
The law of the law of conservation. The law of conservation of energy. The law of conservation of energy tells us total energy of the ball. Total energy of the ball when it is at capital A equals the total energy of the ball, total energy of the object when it reaches to B. Total energy of the ball at A means total initial energy. Total energy of the ball when it reaches to B means total final energy. It's a solid object. For a solid object, the total energy is the summation of potential energy and kinetic energy. So total energy at A means potential energy of the ball when it is at A plus kinetic energy of the ball when it is at A. So total energy at capital B means potential energy of the ball when it is at capital B and kinetic energy of the ball when it reaches to B. Can you do the rest and find this velocity v from the second method, dear? Please give a try. So there are two potential energy terms. So let me use for the potential energy at A, let me use mgh1, kinetic energy half mu square. Second potential energy mgh2, kinetic energy half m v square. Can you see the board there when I write here? Are you able to see that edge? Can you see the board clearly? Right. mgh1. What is h1 there?
Yes.
mgh1 is the distance to the object from the ground at the beginning. When the ball is at A, distance to the ball from the ground is h1, so that is 100. Plus half m, initial velocity is 0, equals mg, what is h2 dear? mgh2. h2 is the distance to the ball from the ground when it is at B. So B point is on the ground. So when the ball is on the ground, when an object is on the ground, distance to the object from the ground is 0. Clear? Is there any gap between the object and the ground? No, because object is already on the ground. So when an object is on the ground, distance to the object from the ground is 0. So h2 is 0. Plus half m v square. Do we want the term mass dear? Somebody unmute the mic and tell me. Should we know the mass, the value of
No,
mass?
sir.
No, sir. No,
No,
sir.
why?
No, sir.
Why?
No, sir.
Reason? Because all the mass
So because all masses can be cancelled.
all the mass terms are cancelled out. The value of G is 10 into 100 plus 0 into anything 0, 0 into anything 0 plus half V square. So this is 1000 equals half V square. If I take 2 to this side, 1000 times 2 equals V square. It means V square equals 2000. So V equals square root 2000. V equals square root 2000. So as earlier, we can write 2000 like this. For the 2000, we can write 400 times 5. So this is 400 times 5. Square root of 400 is 20 root 5. So velocity is 20 root 5. Got it? Write them all here. Who got the answer even from the second method? If you have a doubt, send a message Zoom chat. Sometimes I do not hear your audio clearly. So if so, the best thing is sending a message, or if you unmute the mic, talk to me loudly. Right? Shall we go to question number 4? Shall we go to question number 4? Right, question number 4. In a game to run a distance of 400 meters, a sprinter starts at rest and runs 200 meters with a constant acceleration. of 0.2 meter per square seconds. The rest he runs with the obtained velocity. In a game to run a distance of 400 meter, a sprinter starts at rest and runs 200 meter with a constant acceleration of 0.2. The rest he runs with the obtained velocity. What is this maximum velocity? Calculate the total time taken to complete the race. Right, let's give a try. Right, so what is the total displacement, the total distance of the race? 400 meter. 400 meter. Right, I want to erase this board because I want some space to write. So if you want, please take a screenshot. I'm going to erase everything. Right, question number 4. I stopped at question number 4. After that, I'll start a separate paper, separate questions. Right. There is a game to run a distance of 400 meters. The boy starts at A. He travels 200 meters with an acceleration. The other 200 meters he travels with the obtained constant velocity. So velocity of the boy at capital A is 0. A to B, he travels with an acceleration. Then he gets a certain velocity V. He does not change his velocity, this obtained velocity V, until he reaches to the point C. This is the story. A to B displacement is given as, let me take S1, 200 meter, but time T1 not given. B to C distance is also 200 meter because the total distance is 400. If A to B 200, B to C should be 200, then only the total becomes 400. We don't know what the T2 is. We don't know what the T2 is. A to B, there is an acceleration. This acceleration is given as 0.2 meter per square seconds. Please draw this figure here. Draw this figure and mark the given data. After that, let's give a try. Quick. Right. Before you start the question, I have to ask. I have a question for you, dear. What is the acceleration of the sprinter from B to C? Somebody please unmute the mic and tell me the acceleration of the boy when he is running from B to C.
No acceleration, sir.
No acceleration. Reason? Reason? Acceleration is defined
Because
as
he
the
is
rate of change of velocity. Am I
running
right?
in the
Yes, you are correct. Very good. Acceleration is the rate of change of velocity. Is there any change of velocity from B to C? No. If the velocity at B is 10 meter per second, velocity at C is also 10 meter per second. So B to C, no change in velocity. No change in velocity means no acceleration. Acceleration is the rate of change of velocity. No change in velocity means no acceleration. Now the second question is, A to B object is moving with the acceleration. It means what will happen to the velocity of the boy when he runs from A to B? Will the velocity be increased or decreased or remains unchanged? Yes, dear?
increase.
Increases, sir.
Velocity increases. When the boy runs from A to B, velocity increases. B to C, no change in velocity. So, at which point the person, this boy has his maximum velocity. A to B velocity increases, B to C velocity remains unchanged. Therefore, what is the point that the boy has its maximum velocity?
B, sir.
B, sir.
At the point B, velocity at A is 0. Velocity may be increased as 1 meter per second, 2 meter per second, 3 meter per second, 4 meter per second, 5 meter per second. Let's say velocity of the boy at B is 5 meter per second. After that, velocity remains unchanged, and until he reaches to C, velocity remains unchanged as 5. So 5 meter per second is the maximum velocity. He reaches, the boy reaches that velocity at the point B. Therefore, please mark the velocity of the boy is maximum when he reaches to the point B, and he keeps that maximum velocity until he reaches to the point C. Who would like if I explain this Vmax case again? Anybody in the class?
Sir, you have muted.
Sorry, thank you. Right. So what is the velocity of the boy when he is at A? 0. Then velocity increases as 1 meter per second, 2 meter per second, 3 meter per second, 4 meter per second, 5 meter per second. So what is the velocity of the boy when he reaches to be 5 meter per second? What is the velocity of the boy when he reaches to be 5 meter per second? So initial velocity A is 0. Velocity at B is 5. After that, velocity is not changed. Velocity remains unchanged as 5 meter per second until he reaches to C. Got it? So maximum velocity is 5 meter per second. Boy obtained that 5 meter per second maximum velocity at the point B. So I have marked the velocity of the boy as 5 meter per second at the point B. Got it? And he does not change this velocity until he reaches the point C. That's what I have said. Now, the time t1 is not given. The time t1 is not given. Therefore, A to B, I should not apply any equation with the term simple t. Why don't I apply any equation with simple t from A to B, dear? What's the reason? Because the time
Because
t1
time is not given,
known.
sir.
Very good. Because time is not given. So when time is not given, we should not use any equation with the term simple t as our first equation. So the only equation without the term simple t is v square equals u square plus 2a s. The velocity at the point B is v max. Velocity at the point A is 0 plus 2, acceleration is 0.2, displacement is 200, S1 displacement 200. So V max square equals 0 plus 2 times 200 is 400. 0.2 can be written as 2 by 10. Can you understand this maths here? 0.2 can be written as 2 divided by 10. 2 divided by 10, 0.2. 2 into 200, 400. Now, we can easily cancel out this 0 and this 0. Finally, we get 2 times 40. V max square equals 2 times 40. It means V max square equals 80. Who got this answer here? We won't find V max, not the V max square, but who got V max square is 80. If V max square is 80, if V max square is 80, V max should be root 80, square root 80. V max square is 80, therefore V max is square root 80. Square root 80 can be written as 16 times 5. Shall we check? 5 times 6, 30, 0 is written, 3 remaining. 5 times 1, 5 plus 3, 8, 80. Square root of 16 is 4. 4 root 5 meter per second is the maximum velocity obtained by the boy. Complete it, dear. Complete this. Right, now we can find simple t. Now we know the V max velocity, we can find simple t easily. What should we do here? A to B, we must indicate the section that we apply the equation. We must indicate the section that we apply the equation. We apply the equation from A to B. Then we must indicate the direction. Why should we indicate the direction, dear? Because we are dealing with vectors. When we work with vectors, we must indicate the direction. Now we apply the equation V equals U plus AP. Velocity at the point B, V max. Velocity at the point A is 0. U is the velocity at A. V is the velocity at B. Velocity at B, V max. U is 0. Acceleration A1, time taken T1. We have found that V max as 4 root 5. 0. A1 is 0.2. T1 is the thing that we want to find. So 4 root 5 equals 0.2 can be written as 2 by 10. This is T1. 10 can be taken this side, 2 can be taken this side. 4 root 5 into 10 divided by 2 equals T1. 4 root 5, 10 divided by 2 is 5 equals T1. What is 5 times 4 here? 5 times 4? 20. So you get T1
20,
equals
sir.
20 root 5 unit is seconds. Who got this answer? Who got the answer of T1 earlier? Right, now we want to find only T2. To find T2, we can use this following method. Star point and write. Star point and write. The person moves from B to C. The person moves from B to C with a constant velocity of V max. The person moves from B to C with a constant velocity of V max. From B to C, the person moves with a constant velocity of V max. Full stop. Therefore, as the velocity is constant, comma, the following equation can be applied. As the velocity is constant, the following equation can be applied. As the velocity is constant, the following equation can be applied. If you want to repeat, please tell me. Right. I want to erase the things that are written in blue color. So if you want, please take a screenshot. I'm going to erase. I have said as the boy moves from B to C with a constant velocity, the following equation can be applied. As the boy runs from B to C, moves from B to C with a constant velocity, the following equation can be applied. That's what I say. So when an object is moving with a constant velocity, we can apply the equation B to C. We can apply the equation velocity equals displacement divided by time taken. We can apply this equation only when the velocity is constant. If an object has an acceleration, then we should use the equation V equal U plus AT. What's the difference? What is the difference between this velocity equal displacement divided by time and V equal U plus AT equations, dear? this one, velocity equal displacement divided by time taken, can only be applied when the velocity is constant. This equation can be applied when the object has an acceleration. That's the difference. So here, no acceleration. Let me apply this. Velocity from B to C is Vmax. Displacement from B to C S2 time is T2. So if I use cross multiplication like this, I can subject T2 equal S2 divided by Vmax. S2 divided by Vmax. So T2 equals S2 is 200. Vmax is found as 4 root 5. Can you simplify this further, dear? Can you simplify this further? Try to obtain the simplest form of T2. Try to find the simplest form of T2, dear. There are many methods to simplify. T2 equal 20 divided by 4 is 50. 200 divided by 4 is 50 divided by root 5. But this can be further simplified. Can somebody tell me how to simplify this further, dear? 50 can be written as 10 times 5. Are you okay with this, Max? 50 can be written as 10 times 5. And 5 can be written as square root 5 into square root 5. Do you know this, Max? If you multiply square root 5 by another square root of 5, you will get the answer as 5. Root 5 into root 5 is 5. And we have divided by root 5. Now this is 10. This root 5 and this root 5 cancelled out. So finally, the time taken T2 is 10 root 5 seconds. Who got this answer? Who got this answer? Right. The final thing is the total time taken. So what is the total time taken for the motion, dear? Hmm? The total time taken. The total time taken equals T1 plus T2. T1 is 20 root 5. T2 is 10 root 5. Now you say that square root 5 is common. Root 5 common. So let me take square root 5 out from a bracket. So the remaining terms 20 and 10. 20 plus 10 is 30. So that is 30 root 5 seconds. So this is the total time taken for the race. And I'm going to stop with this question. I'll start a new section, new questions, new set of questions from this. Right. So you should try to do the rest of the questions at home. When I have a free time, I'll discuss those questions also. Please check your WhatsApp groups, dear. Please check your WhatsApp groups. Please check whether you have received the paper. I don't know whether you have received it or not, but please check your WhatsApp groups, dear. If the paper is received, please
Yes,
tell
received.
me a question.
Yes, sir.
Please check the groups again if you have, if it is not received there. Right, now I think you have received it. It is given in 2014 AL paper. The first structured essay question of 2014 AL paper. Read it. Okay, let me show you the paper. Right. I think you are able to see it. Right. Please write the heading 2014 first structured essay question. 2014 first structured essay question. Let me read the question. The following measuring instruments are given to determine the density of a material of a small uniform cylindrical container of the form shown in the figure. So what are the things that they have given? Vernier caliper and electronic balance. Right? So we have to find its density. Before using vernier caliper for taking measurements, what is the first step that you should take? Before we take any measurements, we should do something first. Can somebody unmute the mic and tell me what should we do first?
So to see whether there is an zero error.
We must check whether there is a zero error or not. But how do we do it then? How do we check whether the instrument has a zero error or not? No need to write the questions, right? No need to write the questions. So we move the vernier caliper section. We kept the external jaws in contact and we check whether the instrument has a zero error. 2014 question number 1, first structure is a simple A question. Please write. External jaws are kept in contact. Please write. External jaws are kept in contact and it is checked whether the instrument has a zero error.
Sir, can you please repeat?
So how do we do it, dear? We keep the external jaws in contact and we check whether the instrument has a zero error. Okay or not? Right. After that,
Excuse.
please ask again. I didn't hear you properly. Sorry, I didn't hear you properly. Please ask it again.
So what is the topic, sir? 2014 A.
2014 first structured essay question. 2014 first structured essay question. Simple A. Answer for simple A is external jaws are kept in contact and check whether the instrument has a zero error. External jaws are kept in contact and it is checked whether the instrument has a zero error. Okay, dear? Right, let's go to simple B.
Okay, sir. Thank you, sir.
Okay, dear. Right, let's go to simple B question. Write down an expression for the density of the material of the container in terms of volume of the material V and mass. So what is density of anything, dear? Density of anything equals mass or volume. Am I right? Am I right, dear? Lamai?
Yes, sir.
Yes, sir.
Density
Yes, sir.
equals mass or volume. Mass is capital M, volume is V. But they have given us the term simple D. So, final answer is density of the material of the volume of the cylinder is equal mass capital M over the volume of the material is capital V. Can you see it there? Can you see this?
Yes, sir. Can see, sir.
Right. So please write it there. This is the answer for simple B. Density equal mass or volume. Put an arrow like that. Then D equal simple D equal capital M over capital V. Okay. Right, shall we go to question, next question, dear? Shall we go to next question? In addition to the two measurements, the outer diameter, the inner diameter of the container, state the other measurements that you would take using the vernier caliper to determine the volume of the material. In addition to the outer diameter and inner diameter, what are the other things, measurements that we want from the vernier caliper to determine the volume of the material? Let us check the figure first. Let us check the figure first. Outer diameter, inner diameter, they have given. So what are the other things that we should measure here?
So external height.
Yeah, we should measure the height of the cylinder. We don't say external height, we should measure height. Because we can use the term depth. So what's the first thing? H1. So please write height of the cylinder. Height of the cylinder. If you want within brackets, H1. Height of the cylinder. Next one. Second measurement. We should measure the what's the second measurement here? Depth of
Sir,
the
depth.
hole. Depth of the hole within brackets H2. Dekai. Venemonal. Inner diameter, outer diameter, height, depth of the hole. They have said three measurements. Neither. What should be the third measurement? Think.
So can you please repeat the second one?
Depth of the hole. Depth of the hole. Actually, there are only these measurements. So the other one is, so we should measure H1, H2, internal diameter, external diameter. So there is nothing to be measured further. The other thing is we should find the zero error. So third one, zero error, right? And it's better to write zero error as the first measurement, but it's okay. Even in the previous question, we have indicated it. So what are the measurements that you want to take here? Height of the cylinder within brackets H1. Depth of the hole within brackets H2. Third one, zero error within brackets simple E. Zero error within brackets simple E. Okay, dear? Right. So then let's go to the next question. A complete, B complete, C complete, D. The figure Roman number 1 to Roman number 5 below show all the relevant positions of the main scale and vernier scale pertaining to one set of measurements that has to be taken in order to determine the volume of the material of the container. Relevant jaws, depth rod that are being used to take each measurement are shown below on the right hand side of the figure. Right hand side of the figure shows here external jaws touch each other. Here there's a gap between external jaws. Now, right, I will try to increase the size of the figure. What is this arrangement here? What is this arrangement? For what we use this arrangement? Somebody?
Zero error.
So to find the zero error.
Very good. The first figure is used to find the zero error. Shall we give a try to find zero error? Wait. I think size is not enough to see the things. Let me increase the size. Now okay. Right, now somebody please tell me the coincide number. What is the coincide number?
So 2.
3,
Number 2.
2,
2, sir.
2,
Number 2 is the coincide number. Right. So capital N equals 2. Is this a positive zero error or a negative zero error? You see, vernier scale zero line is at the
Positive 0 error, sir.
positive 0 error.
so
Positive
Positive
zero error.
0 error, sir.
very good. Therefore, this is a. So please write the first figure shows. So please write the first figure shows a positive zero error. Good. You can write in the point form, right? After that, let's fill the table and do the things. So please write the first figure shows a positive zero error. Positive zero error. How do you find positive zero error here? Least count into Lamai
N,
coincide.
sir.
Least count into coincide number. So what is the least count of this instrument?
0.1 millimeters.
0.1 millimeter.
0.1
0.1 millimeter. So least count is 0.1 millimeter. Coincide number 2. Therefore, what is the zero error here? What is the zero error? Zero error is 0. Please write the things. 0.2 millimeter. 0.2 millimeter. Got it? Okay, Lamai?
Okay, sir.
Right. If you want, you can take a screenshot. What do you think about the second figure here? Second figure shows external jaws and the measurement is slightly greater than 2 centimeter. What do you think here? We use external jaws to
Outer diameter.
yeah. We use maybe external diameter or maybe height. Listen dear, we use external jaws to get 2 measurements. What are the 2 measurements that we obtain from external jaws dear? Height of the cylinder and external diameter. Now to obtain the answer, we should go back to the figure and check which is bigger. Can you understand here? We should go back to the figure. Now look at figure. Which is bigger here? External diameter or height of the cylinder?
Height, sir.
Height
of
of
the
the
cylinder.
cylinder, sir.
Very good. Height of the cylinder is bigger. So external diameter is small. Height means this one. This height is bigger than the external diameter. Now let's go to the figures. So in external jaws figures, how many external jaws are there? Here we have one. It is 3 centimeter something. So it means this one is larger and this is smaller. Therefore, which is the external diameter? The second figure or the fifth figure?
Second figure.
Second figure, sir.
Second figure, because second figure shows a smaller measurement. Second figure shows a smaller measurement. So therefore, it should be external diameter. Fifth figure shows a larger distance. Height of the cylinder is larger. Therefore, fifth figure should be larger. Put a star point and write. Put a star point and write. External jaws are used. External jaws are used to obtain 2 measurements. Star point and write. external jaws are used to obtain two measurements. Within brackets, external jaws are used to obtain two measurements. Within brackets, please write. Within brackets, please write external diameter and the height of the cylinder. External jaws are used to obtain two measurements. Within brackets, please write external jaws are used to obtain two measurements. Within brackets, please write external diameter and the height of the cylinder. And the height of the cylinder. Continue. According to the given figure of the cylinder, its height is larger than, according to the given figure of the cylinder, comma, its height is larger than, its external diameter. According to the given figure, its height is larger than its external diameter. Okay, dear. Would like if I repeat that sentence? Anybody in the class? Right. Therefore, we should take the largest measurement. Therefore, we should take the largest measurement taken by the external jaws. Therefore, we should use the largest measurement taken by the external jaws as the height of the instrument, as the height of the cylinder. Therefore, we should use the largest measurement taken from the external jaws as the height of the cylinder, full stop. The smallest measurement taken from the external jaws, should be used as the external diameter. The smallest measurement taken from the external jaws should be used as the external diameter. Full stop. Therefore, second figure shows the measurement of external diameter. Therefore, the second figure shows the measurement of the external diameter. Therefore, the second figure shows the measurement of external diameter, and the fifth figure shows, the height of the cylinder, and the fifth figure shows the height of the cylinder. Okay, dear. Who would like if I repeat it? Anybody in the class? Right. Leave a line and write. According to the leave a line and write. According to the second figure. According to the second figure, the main scale reading is. According to the second figure, the main scale reading is. Somebody please tell me the main scale reading here. Somebody in the class.
20 millimeters.
Yes, dear. Main scale reading. This is the vernier scale zero line. Vernier scale zero line. If you start from the vernier scale zero line and if you try to go towards the main scale zero line, start from the vernier scale zero line and if you try to go towards the main scale zero line, the first number that you find on the main scale is 2 centimeters. So main scale reading, MSR, main scale reading is 2 centimeters. It means how many millimeters there? How many millimeters there?
20 millimeters, sir.
Right. So please write. According to the second figure, the main scale reading is 2 centimeter within brackets 20 millimeter. According to the second figure, the main scale reading is 2 centimeter within brackets 20 millimeter. According to the second figure, the main scale reading is 2 centimeter within brackets 20 millimeter. Now, according to this figure, what is the coincide number? What is the coincide number?
2, sir.
2, sir.
The coincide number is 2. You see? Right. Next line. The coincide number is 2. The coincide number is 2. The coincide number is 2. If you want, please take a screenshot. The coincide number is 2. If you want, please take a screenshot. Now leave a line and write outer diameter equals main scale reading. Look at and write outer diameter equals main scale reading plus vernier scale reading means least count into vernier scale reading means least count into coincide vernier number. Can you understand? LC into N is the vernier scale reading. So outer diameter equals main scale reading plus least count into coincide number. Least count into coincide number means vernier scale reading. Main scale reading is 20 millimeter plus vernier scale reading. Least count is 0.1 millimeter. 0.1 millimeter multiplied by coincide vernier number is 2. So this is 20 plus 0.1 into 2 is 0.2. 0.1 into 2 is 0.2. So 20 plus 0.2 means 20.2. 20.2 millimeter. Got it, dear? If you want, please take a screenshot. If you have any doubt, please ask. 20.2 millimeter. Okay? Right. So what do you think about the third figure here? What do you think about the third figure?
Internal.
It is the
Diameter.
internal. It shows the internal diameter. So you say internal jaws are shown
Excuse me,
clearly.
sir.
Yeah. Yes,
Sir, for the
dear.
second diagram, we should subtract from the positive zero error.
Sorry. What's the equation that we have written here? I forgot the equation that we have written. Have written
So we have written outer diameter.
outer diameter equals this. So please cut the term outer diameter and write reading shown in second figure. Reading shown in second figure equals MSR plus VSR, LC into coincide number. So this is the reading shown in the second figure. Okay, dear? So reading shown in the second figure is 20.2 millimeter. Right. I forgot one thing. What's the point that I have forgotten there? What's the point I have forgotten? I have forgotten that instrument has a positive zero error. So as the instrument has a positive zero error, we must subtract the positive zero error from this instrument. That's how we get the correct measurement. Right. Star point and right. The reading shown in the second figure equals MSR plus LC into N. Star point and right. As the instrument has a positive zero error, as the instrument has a positive zero error, comma, as the instrument has a positive zero error, comma, that error should be subtracted from the reading. That error should be subtracted from the reading. As the instrument has a positive zero error, comma, that error should be subtracted from the reading. Okay, dear? Right. As the instrument has a positive zero error, comma, that error should be subtracted from the reading. So leave a line and write, therefore, the correct outer diameter, therefore the correct outer diameter, therefore the correct outer diameter, the correct outer diameter equals, look at board, equals, reading is 20.2. What is the positive zero error here?
0.2, sir.
0.2. Therefore, outer diameter equal 20.2 minus 0.2. So that is 20 millimeter. That is 20 millimeter. Okay, dear? Right. Outer diameter 20.2 millimeter. Sorry, 20 millimeter. If you want to repeat anything, if you have any doubt, please ask. Send a message to Zoom chat or unmute the mic and ask. Right, shall we go to figure 3, dear? If you want, please take a screenshot. If you want, please take a screenshot. I'm going to erase everything. I'm going to go to figure 3. Now somebody please tell me the measurement shown in figure 3. Somebody
So the
unmute
internal
mic.
diameter.
Internal diameter.
Internal diameter, very good. So
Internal
please
diameter.
write. Figure 3 shows the measurement of internal diameter. The figure 3 shows the measurement of internal diameter. Full stop. The main scale, figure 3 shows the measurement of internal diameter. The main scale reading is, somebody please tell me the main scale reading there. Look at the screen and tell me.
6 millimeter.
6 millimeters.
It is
1.6 millimeters.
This is 2 centimeter. 2 centimeter mean what should be this dear?
16
The
millimeters.
16 millimeters.
Sorry.
16 millimeters, sir.
This is, sorry, it is not clearly indicated. This is 1 centimeter. 1 centimeter. 1 centimeter means 10 millimeter. 11, 12, 13, 14, 15, 16. So what is the main scale reading there? 16 millimeter. So please write. The main scale reading is 16 millimeter. So you can take a screenshot after I have written everything. The main scale reading is 16 millimeter. Right. So what is the coincide vernier number here? This is vernier scale 0, right? This is the, it's not clearly indicated on the figure. That is vernier scale 0 line. So what is the coincide vernier number here?
So 2.
3. 2, sir.
2, nail.
2.
So here also coincide number, this is 1, this is 0, this is also, this is 2. So here also coincide number is 2. Coincide vernier number is 2. So please write the coincide vernier number is 2. The coincide vernier number is 2. If you want now, you can take a screenshot. If you want now, you can take a screenshot. Coincide number is 2. Okay, dear? Right. Then leave a line and write the equation. Therefore, the reading shown in figure 3. Therefore, the reading shown in figure 3 is MSR plus the reading shown in figure 3. MSR plus least count into coincide vernier number. MSR plus VSR. MSR is 16. Least count is 0.1. Coincide number is 2. Therefore, what is the reading there? Therefore, what is the reading? Somebody?
0.2.
16.2 millimeter. Very good.
6.
So please write, therefore, the reading equals 16.2 millimeter. If you want, you can take a screenshot. Okay. Third figure shows the measurement of internal jaws, but the instrument has a positive 0 error. So therefore, we must subtract the positive 0 error from the reading. Leave a line and write, therefore, the real internal diameter. Therefore, the real internal diameter equals, how do you find it here? The real internal diameter means reading 16.2 minus error 0.2. So what should be the correct internal diameter here? Hello?
So 16 millimeters.
Correct internal diameter should be 16 millimeter. Right. Now, listen dear. I'm going to do something like this. I have taken 3 measurements. Take the 3, if you want, please take a screenshot. You must try to find the reading of Roman 4th figure and 5th figure at home. What should you do here? You should obtain the readings shown in figure 4 and 5 at home. Wait. Then, because this is a paper class, if I do all the things by myself, it will be useless. Right. So try to obtain the readings of figure 4 and 5. You should understand that figure 4 shows the depth, 5 shows the height, and they have given us a table. They have given us a table, right? And you should fill that table also. I'll send you the questions. I'll send you the questions to the questions. You should try to fill the table also. You should try to fill the table also. Okay? And you should send answers to the WhatsApp groups. Then I'll check. And I wish to discuss the rest of the question next week. Okay, dear? Agree or not? Right. So
Agree, sir.
right. So I'm going to stop the class today. So try to find the reading shown in figure 4 and figure 5, and do not forget to subtract the 0 in it. There is a table. Try to fill that table. I'll send you the question and write the complete answers. So I think that method will work properly. See you this Tuesday morning and or Wednesday afternoon classes. The most important class is Tuesday night class 8 to 11 mechanics class. So let me stop the class now. See you. Good luck. Bye.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.
Thank you. God bless you.
Thank you, sir. Bye, sir.